Okay, so now we will discuss type of questions they will ask in exam. We will discuss these questions. These are enough to solve the mains and advanced questions. Okay, by solving these questions you cover aromatic compounds, non-aromatic compounds and anti-aromatic compounds totally. Okay, okay, now okay, we will discuss all. We already discussed now how you will distinguish aromatic, non-aromatic and anti-aromatic compounds. For aromatic, there should be sp2, odd pi bond, means aromatic. Okay, now for non-aromatic, sorry, anti-aromatic, this is sp2 and even pi bond. And for non-aromatic, the system should be non-planar, means sp3 notation. By these points you can find the. So first you have to check the hybridization. If it is all carbons are sp2, that means they will go in category of aromatic or anti-aromatic. If the compound have sp3 hybridization, then definitely that will go in non-aromatic compound. If they have pi bond, that means aromatic. If odd pi bond is aromatic, if even pi bond is anti-aromatic. Now second is by Frost cycle also you can find which one is more aromatic. So what is the Frost cycle here? If I have this benzene and I am making this anti-bonding compounds, bonding and anti-bonding compounds. So these are bonding, this is Fermi level, this is the bonding molecular orbital, and these are anti-bonding molecular orbital. So benzene have how many electrons? 6 electrons. So we will fill one by one. So 1, 2, 3, 4, 5, 6. So all electrons are lying in bonding molecular orbital. That means that benzene is stable, that benzene is aromatic. Okay, if all are going into bonding molecular orbital, that means that compound is aromatic. Okay, let's see if we are taking some other example, and I am going to see this one from first cycle. First, just keep the टिप पॉइंट है, ये जो लास्ट का बिल्कुल नोबुलर पॉइंट है ना, उसको आपको रखना है. सो वी विल डिस्कस लाइक दैट. दिस वन विल मेक दिस वन, दिस वन, दिस वन, दिस वन. So this is the bonding into. So how many electrons are there? 4 electrons are there. So we will fill one by one. 1, 2, 3, 4. So 2 electrons are going into anti-bonding of molecular orbital. That means that compound is anti-aromatic. So by Frost cycle also you can check which compound is aromatic and which compound is not aromatic. Now there is some exceptions here. This one is a octatetraene. The examiner will ask octatetraene is a aromatic or anti-aromatic or non-aromatic compound. So you have to see. Now according to this, all have sp2 hybridization here. All carbons have sp2. Okay. Now how many pi bonds there? 1, 2, 3, 4. 4 pi bond. That means non-aromatic. Okay. According to this, that will go in non-aromatic compound. But what will happen here is that compound is not like that. How? Like this compound will go in, we will make here. Now we will erase this one. This compound will go in like that. This is sp2 for pi system is anti-aromatic. Okay. This should be anti-aromatic. But it is not anti-aromatic. Why? This structure exists in tub-like structure. This type of structure. Okay. Due to this tub-like structure, it will go in non-planar. And due to non-planar, this compound is non-aromatic. Why it is going into tub-like structure? Because of angle strain here. There is too much angle strain. So due to angle strain, it will not exist. It is not stable in that compound. In that one, it is not stable in that one. It will exist in tub-like structure. So that compound is non-aromatic. Example is octatetraene is aromatic or non-aromatic. So you have to have that compound is non-aromatic. Now this is the first example. Now second example we will discuss here, aniline type. This system, according to this, we all have sp2 hybridization, and second one 1 2 3 4 5 pi bond. Means it should be aromatic. So, but this system is not aromatic because these hydrogens will create a repulsion. So due to repulsion, these hydrogens will go in out of the plane like that. These hydrogens, they go in out of the plane. So because of that, the system will become non-planar. The system become non-planar. So this system is a non-aromatic. Correct? So if you have aniline type, so this system also non-aromatic compounds. Now for type we have a polycyclic conjugated system. In that system we will not calculate one lone pair between one heptene. Why? We will check first delocalization. So in that compound, that first compound here, all are sp2 hybridization. First is that it is planar compound. Now second one, how many bonds are going into delocalization? Here this bond will go in delocalization, this bond will go in delocalization, this bond will go like that, this bond will. So this lone pair is not involved in delocalization. This lone pair is not involved in delocalization. So we will count only these pi bonds which are involved in delocalization. So here how many pi bonds are there? 1 2 3 4 5 pi bonds. This lone pair is not involved in resonance. So because of that we will not calculate it 4n plus pi 2 according to anti-aromatic or n pi system. We will not calculate this one. So now how many pi bonds are there? 1 2 3 4 5 pi bond. That means that system is aromatic. Now for this system, so we can say also this lone pair is a Huckel lone pair. Now this one all are sp2, and this lone pair, this bond, this bond, this bond, this bond, this bond are going in delocalization. This bond is not involved in delocalization. So it is sp2 1 2 3 4 5 6 pi bonds, means the compound is anti-aromatic. So we can say this double bond is a non-buccal bond. So whenever we use this type of polycyclic conjugated systems, you have to see which one is going into delocalization. So that bond going delocalization, we will think like that. Now, second, fifth one, they will ask like polycyclic non-benzoate system. Okay, non-benzoate system, they have polycyclic systems but not benzene. We have some like 5-membered ring, 8-member ring, 7-member ring. They will attach, they will fuse together. 5-membered ring and 7-membered ring, they can fuse. The 3-membered ring and 7-membered ring, they can fuse, but not benzene system they will fuse. So we have a polycyclic system. So according to, if we have a non-polycyclic system and non-benzoate system, then we will find according to cracks. Okay, so for cracks, first the system should be cyclic and other one is planar, like sp2 hybridization. Now if we have a polycyclic non-benzoate system, how we will find this ring and this ring are fused by one bond. Okay, so this one and this ring and this ring is fused by one single bond. So this system is a polycyclic non-benzoate system. Now how we calculate how many that system is sp2 and how many pi bonds are there? 1 2 3 4 5. 5 means odd, third means aromatic. Now if we are doing this example, so this one is also non-benzoate system. These two rings are fused. That one is polycyclic and non-benzoate system. That one is cyclic and planar, all are sp2. So sorry, I gave this one incorrect. That one is non-aromatic. If we have a non-benzoate system, then we will get aromatic, otherwise non-aromatic. Okay, not we will get aromatic. So we will have only aromatic and non-aromatic. Means if I have a n is equals to pi bond is equals to 4, that means aromatic. If pi bond is even, then non-aromatic. Okay, so first one is aromatic and second one is for pi bond sp2 is planar. So that one coming non-aromatic. Now in 6th point, examiner can give one reaction and they can say that compound is aromatic or not. After reacting this substance, that compound is aromatic or not. So Na, what is the property of Na? Na is a base, so it will extract it. It will give one electron system, means one electron. It will donate one electron. That means it will give one electron to the system. Okay, one negative charge will go to the system. Now how many bonds are there? That is sp2. Then we will form this compound. That one is sp2. And how many pi bonds are there? 2 pi bonds. One is this and one is this. So that compound is antiaromatic. Now after that, this AgNO3 will give, it will take Er because it have vacant d orbital. So bromine have lone pair, it donate to that lone pair to in the vacant orbital of Ag. So it will become deficient. So because of deficient, this bond will like that move. It will give electron to Br positive and here positive charge K. So now what is the property of AgNO3? It will extract plus 3 Br. So So what is the compound? This compound has sp2, and how many pi bonds are there? One pi bond, means all pi bond. That compound is aromatic. Now the benzene, naphthalene, anthracene and phenolphthalein all are aromatic compounds. These all are aromatic. Now third is azulene type system, like that. Okay, what will happen here? This bond move this side. Okay, now here this will show the movement of electron. Then electron will come here, means negative charge will come here and positive charge will come here. So this system is like that. So if I'm going to see this system, then how many bonds are there? 1, 2 and 3. So 3 means aromatic, that ring is aromatic, and this one also 1, 2, 3. This ring is also aromatic. So both are aromatic. Due to high dipole moment, this system is aromatic system. If this system is azulene system, examiner can ask azulene system is aromatic. Why? Because of high dipole moment. Because it has high dipole moment and positive negative charge, they dissociate. And these both rings become aromatic and aromatic because of that it has high dipole moment. So this compound is aromatic. If examiner gave electronegative atoms in system, so here what is happening now? First you have to see all are sp2 hybridized or not. This one is sp2 hybridization, 1, 2, 3, 4. That one is sp2. That one is also sp2. Okay, now first you see the delocalization, which electrons or which pi bond and which lone pairs are going to delocalization here. So this lone pair will move this side and this bond move this side and this bond move this side. So these two bonds and this one lone pair of oxygen are going into delocalization, not that one. So what is the hybridization of nitrogen? 1, 2 and 1 lone pair. It will not go in delocalization, so we will count in hybridization. So 2 sigma 1 plus 1 lone pair 3. So it is sp2 hybridization. It is a sp2 hybridization. Okay. Now 1, 2. This lone pair is going into hybridization. Means this lone pair of oxygen is going involved in delocalization here. So this one is also sp2 hybridization. So this system is sp2 hybridization. Now what will happen here? I will calculate the number of electrons that going into delocalization, the number of carbon that going into delocalization. So 1, 2 and here 1 lone pair of oxygen going into delocalization. So how many pi bonds are there? 3 pi bond. 3 pi bond means aromatic. Now if this system, we have this system 1, 2, 3. This negative charge is going into delocalization. So it have sp2. The system is planar, and how many pi bonds are there? 1, 2, 3 pi bonds are there. So this system is aromatic. If I have this system 1, 2, 3, okay, 3 pi bond, this lone pair is not going to delocalization. This one is localized lone pair. So it is sp2 hybridization, that one not going to delocalization. Only 3 pi bonds are going to delocalization. We will calculate this one. That system is aromatic because it is sp2 and 3 pi bond. This system sp2 1 and 2 even pi bond. This system is a anti-aromatic. Now again here This one is a sp3, so it will go in non-planar system. It is a non-aromatic system. Now this system, it is a 1 system, 1 lone pair and 1 pi bond is going to be location here. This system is a anti-aromatic. This system, you can say this one is sp3 hybridization. So this system is a non-aromatic. Now again we will discuss this example. Now this has 6 pi electron because this lone pair is going into location like negative. Oxygen is more electronegative, like this one will move this side, negative positive partial charges 1 to 3 pi bonds are there, that means 6 pi electron is aromatic. Or you can say 3 pi bond. Okay, now these also two most important examples. What will happen here? Like we will move this double bond here. Now if I am moving this like that, A, if I am moving this side, A. If I am moving A side, then what will happen? Here positive charge will come, here negative charge will come, and this is the system. So this system is this ring is a 1 pi bond, so aromatic, and this system is a 1,2 pi bond. So this is the anti-aromatic. If any one ring is aromatic and one ring is anti-aromatic, then that one is a non-aromatic. Okay. If I'm going, okay, these I will check here. If I'm moving this bond like that, now same only, negative, positive will should come here like that. This ring is like anti, this one is aromatic. So if one ring is aromatic, one is anti-aromatic, and this ring is non-aromatic. Okay, I am going to check this one. If I am moving this like that, P. If I am moving like that, P. If I am going to by A side, if I am moving to A side, then I am moving this bond like that. So here that will come positive and here negative. Okay, now this having how many system? 2 pi means anti-aromatic, and this one is a 1, 2. This is also anti-aromatic. Now if I am going to by B1, what will happen? Negative, positive. How many bonds? 1, 2, 3 bonds. 3 pi bond, that means aromatic. And here that means 1 pi bond, that means aromatic. If both rings are aromatic, then whole compound will become aromatic. So now you can say if both rings are aromatic by moving the bond, if both rings are coming aromatic, then this compound is aromatic. If any one occurring is coming anti-aromatic, so that compound will become non-aromatic. So you can say like that. So if I am giving this ring A and this ring B, if A and B both aromatic, that means this system is aromatic. Now if A and B, any one is anti-aromatic, that means that compound is non-aromatic. Examiner can ask also which one is in both A and B, which one will lie in cis-trans isomerism, which will show cis-trans isomerism. Okay, that one is after moving the bond, that A1 is not forming aromatic compound, it is becoming non-aromatic after moving the double bond. So this one line is trans. Right, because cis trans will show double bond and two groups should be there. Okay, now in this one, this is lying into single bond rotation, because after moving the bond it is forming aromatic compound, so that's why this will exist in that form. So because of that it is not forming double bond, it is more stable in single bond, so that one going. So only first one will show cis trans isomerism. If examiner is asking which will go in single bond rotation, in between A and B, which will go in single bond rotation. So through single bonds we can rotate the bond, so B part will go in single rotation. So for A, if I am going to see cis trans, A will form cis, B will not form. If I am asking single bond rotation, then A will not form, B will form single bond rotation, because it moves to aromatic. Okay, this one. So next one we finish all examples here. We discuss all things. Beyond that, no question will come. Thank you.